Today's episode is sponsored by Arvato Systems. Visit them at us.arvato-systems.com.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. If you haven't already, like and subscribe to get new episodes delivered to your inbox each week. I'm your host, Carrie Gitter, Associate Editor at SME Media. I'm joined today by Johannes Fuhrmann, Head of Strategic Business Development at Arvato Systems. Welcome to the show. And our topic today, we'll be talking about data spaces and digital twins. So thank you so much for joining us, Johannes.
Hi, sure, and thanks for having me.
So let's get started on this topic here, just with the basics. So what exactly is a data space?
That's a good question to open this conversation because it's not that easy to define. So what is a data space? In general, data spaces are not a new technology, but especially in Europe where I work, data spaces are coming into the light for solutions revolving around data sharing. The idea of data spaces, though, is not to create a central platform where everyone puts their data and then they can retrieve whatever they want, but it is a rule set of policies, it's digital identities, and it is a way to identify yourself, to identify the data that's available, but you access this data on the systems of your client, customer, or whatever. So there's no data storage in a data space. It's basically a pipeline that's created, that's secure, that's authenticated, and that allows you to share data in between companies, which is especially interesting when you're dealing with sensitive data, right? So, for example, in manufacturing, you have all the data that belongs to you in your systems, the full sovereignty, and you decide what do I want to share via a data space with my business partners, suppliers, or whatever.
And so today in manufacturing, we're in the Industry 4.0 era. It's digital, it's connected, it's smart. So how do data spaces fit into that Industry 4.0 strategy?
Yeah, so what we're seeing in Europe and especially in Germany is that since the advent of Industry 4.0, whatever people understand from this, right? It's different definitions, but let's say the digital transformation of the manufacturing industry. Since the advent of this, there hasn't been a proper rise in productivity as we expected. So we had the wave of automation, the wave of electrification, and you can see in the data how productivity goes up. But now with all this technology coming within the brackets of Industry 4.0, we don't see this increase in productivity. So a lot of universities and consultancies are looking into this and trying to find root causes of this. And what we see a lot is that especially manufacturing companies, but in general companies, they do digital transformation in forms of different experiments, right? They start a POC in this department, they build up an MVP in another department, and they develop digital solutions, but they don't work together. They're built on different tech stacks, they don't have proper data flows. They don't have proper APIs to interconnect to other systems and tools you use in the company. They're like isolated experiments. And this is what we're trying to change with data spaces within the companies. So the idea is also obviously to standardize data, to make it interoperable between systems. So the money and investments you put into digital transformation is not only located in this one use case, but it feeds into like an underlying tech stack to build up new digital use cases. And of course, there's like an external perspective to this as well. A lot of digital transformation efforts so far went into how can I optimize my processes? How can I get rid of paper? And what we're trying to do now with data spaces is also to extend your system architecture beyond the limits of your company. So the idea is to say, let's say I'm missing some logistical data that would improve my processes a lot. I'll ask my logistics provider directly to provide me this data, and in this way I get more efficient. And this is what we think is a good way to create this so far missing productivity from Industry 4.0 by standardizing data, by making it interchangeable, and by creating efficiency together and growing in that way instead of creating more output only.
And do you see this as a trend that's developing globally as well?
Definitely, yes. So especially when it comes to standardization, it's not easy to find a global standard, as you can imagine. But we have, let's say, continental standards. There's the asset administration shell in Europe, and a lot of government bodies and NGOs also work with other continents, with Asia, Japan, and China predominantly, but also with SESME in the US, to align on these standards. And in the end, if you ask me, there will always be like a handful of standards. There will not be like this one standardized meta model for data, but there will be a few, and we are seeing these efforts towards data spaces globally, definitely, yes.
Great. So now let's shift a little bit into the topic of digital twins. Obviously, the digital twin concept has gained a lot of traction in the last decade or so and is becoming more and more widespread. So how do you define a digital twin, and what are some of the use cases of digital twins that you're seeing today?
My definition is not the full definition, but how I would define a digital twin is like a digital CV of my product. It shows me where it has been born, where it was manufactured, who bought it, how it was used, and how it will be recycled. It's like from birth to death, it shows me the life cycle of my product. So you could also call this a digital shadow, right? It's like a digital shadow representation of what happened to the product in real life. There are different definitions for digital twins, which include 3D modeling, the capability to simulate processes before you actually execute them using these 3D models. But I think the more important paradigm shift is to look at these digital shadows, to look at this digital CV, and understand that so far a lot of manufacturing companies work within product categories. So BMW builds the 5 Series 15,000 times a year. And the idea of the digital twin is to not look into product categories, but into single SKUs. So in the example of BMW, every car gets an individual QR code with an individual unique identifier. And to this identifier, I save all the data this single car produced so far in its life cycle. So it's an object-centric data storage that we're looking at here. And this in combination with data spaces is very, very strong, because if you look at this car again, you could exchange data with your suppliers. They give their digital twins to you and you integrate them into the digital twin of your car. What are use cases of this? If a supplier of BMW tells them, oh, well, we found out that 5 of the 5,000 airbags we sent to you were malfunctioning. Right now, BMW has to call back 800,000 cars to find these 5 airbags, and that's a very, very expensive thing to do for them. So if you have this construct of data spaces, data sharing, and the data modeling within digital twins or digital shadows, you can exactly see these 5 pieces are in these 5 cars, and I only need to call back these 5 cars eventually, which saves a lot of money. Another use case area is recycling and circular economy. If this car lands at a scrapyard in one day, you can see from your digital twin what is inside, what can be reused, what has to be destroyed, what can be recycled, etc. And another big area, obviously, is traceability. So where's my product right now? What's the configuration of my product? If you have an IoT-capable product, you can even feed live data into your digital twin, see how it's used. How does customer A use my product compared to my whole customer base? And what can I learn from that? Stuff like this.
And so for a manufacturer today who's interested in taking advantage of these systems and data spaces and digital twins, what would one need to work with them and get started on this process of digitizing?
It is, as I said, it's a paradigm shift. So obviously it's not just 5 minutes work. So you need to put a bit of effort into this. It starts in the physical world that you need to be able to label your products in a way and give them a unique identifier. You need this object-centric way of thinking to make this happen. After this, it's pretty easy. You have some kind of database where you manage your identifiers, where you manage the data that's coming in per identifier. And accessing data spaces is also not that complicated if you don't do it all by yourself. They include a bit of new technology. So what we know from the crypto scene, like wallets and decentralized identifiers, public key infrastructure, these are elements of data spaces as well, because they don't rely on a central entity to manage access. It's a decentral technology concept to do that. And this is a bit tricky to set up, but you as a manufacturer who wants to participate in data spaces only need a connector to connect to them. So there are companies like Arvato, for example, in Germany, but others as well, who offer data space as a service. And then you just need a data connector to feed your data into data spaces or to discover data there and retrieve it. So it is a bit of process work. It is a bit of system integration. It's a bit of data management, but it's not that you need to reinvent your whole system architecture to enter the world of data spaces and digital twins.
And so for a manufacturer who's considering this, you've touched on this a little bit already, but why is having that product data accessible in that way so important?
There are many reasons for different kinds of companies. So if you look at companies that have different steps of sales, so they are not selling to the end customer directly, but there's some kind of trader in between or wholesaler or whatever, they lose touch with their product as soon as they sold it to this wholesaler. They don't know who their end customer is. If you have like a QR code on your product, what you can also do is to say, okay, if my end customer scans this QR code, I will redirect him to some kind of product portal I created, where I see the latest information, where I can get instructions, where I can order spare parts, where I can find a service partner if I need a repair. So you can get into interaction with your customer. You can also advise them sales-wise if they want a new product, another product. You get access to the people who are actually spending the money on your products and not the people in between who are trying to get it into the market. For these companies, that's a very interesting thing to do this. If you're selling to end customers directly, it's still interesting to look into this world of digital twins because there's a whole world of process optimization. Right, so you can track the energy you used in production per product. That's like the level of detail you could get from this way of working. Not per machine, not per factory site, but per product. You could get feedback loops into your engineering. So let's say they engineer a product, they have these digital shadows, and after some time they look into the data they accumulated over time, and they see how are my customers using my products, what are the typical errors that occur. And this is a closed feedback loop to engineering, which they can use to engineer version 2 of this product with real feedback from what's happening, right? And as I mentioned before, the sustainability topic is a huge thing. So sustainability in two ways. First way, what's the material in my product and what can I do with it after the life cycle? But also look into this efficiency topic. So right now, our global world functions in this way that we think, okay, we need to create more output out of factories to grow, right? But there's another way, in my opinion. Let's say, let's take this BMW example again. Let's say they are lacking logistical data, and without this data from their logistics provider, they lose 50 cents per manufacturing process. What they could do in the future is say to their logistics guy, okay, I need this data. I will give you 25 cents per data point. And in the end, in this setup, BMW saves 50 cents because they get the data, they get more efficient. They pay 25 cents to their logistics provider. So there was not more output, but two companies earned 25 cents because they became more efficient together. It's a bit complex, but I hope you get what I mean, right? So the idea is to create transparency, efficiency together, and grow by using less input for the same output. And I think that's the biggest story about this, because we all see that we are running a system that comes to its limits, and there are certain nature barriers that we cannot erase. We have to align to them, and that's why I think it's so important to look for solutions where we can save our resources and still grow as a global society.
And is cybersecurity and data protection a concern for manufacturers who are looking to go through this process?
Yes, and especially in Germany, we love our data so much we don't like to share it at all. But in general, there is hesitation when it comes to sharing data, and that's what's so nice about data spaces. You will keep the sovereignty over your data at all times. It is not leaving your enterprise infrastructure. You can very, very detailed say, okay, this data point is available for these digital identities, and you can rest assured that these digital identities are proven. It's the same as if we would send cryptos in between our wallets right now. I know it's your wallet if you gave me this address. And that's the same technology within data spaces. So it is also for Arvato, for us, it is a part of our data sovereignty strategy. We are taking this as an active element to provide to our customers to say, okay, if you want to be sovereign of your data and still be able to share it, don't look into hyperscalers, don't look into central databases, look into data spaces and decentral technology.
Another question, how does data monetization play into this equation?
That is in parts what I described with the 50-cent process example I just gave you. And it is a bit of a road ahead to get there. So right now in Europe, there are governmentally funded projects that create these data spaces. There are first companies like SAP or Siemens who look into their portfolios and see how they can adjust to this, what they can offer around this. But we're building up this infrastructure. We are creating the processes. We're creating the use cases where we can prove this saves money. The idea in the long run is to say, okay, if we have this infrastructure, if they are connected, if we have this ecosystems of companies sharing data, don't just share them, put them in your shopping window, essentially, right? Let the data space know this is the data I have, this is the data I can offer, and then there's something coming into play which is called smart contracts, so another part of the Web3 crypto world. And then you can create smart contracts for data exchange. And this you can also align with a revenue stream. So you could basically sell your data or purchase the data that helps you to grow more efficient.
Got it. And so looking ahead, both in Europe and globally, would you say that you see the adoption of data spaces growing pretty rapidly in the future?
Right now, yes. Right now it's funded as well. And as soon as something is funded, it grows. So the critical point is still ahead, in my opinion. Funding will run out mid next year. And I'm personally convinced that this topic will grow because I think it's essential for a few topics that we need to solve. But it is a rough time right now to introduce a technology of this magnitude and of this change into declining numbers, cost cutting, and the situation we have right now in the industry, right? So, yes, I think it will grow, but also, yes, I think we need to create like proper use cases that show revenue, that show efficiency within the next year to convince manufacturing company that it's worth to invest in this kind of technology. And it's not just manufacturing, right? So Germany right now completely changes the underlying infrastructure when it comes to health data. So our health data in the future will also be administered in a data space. I will be sovereign of my patient data, but I can choose to share some of that with a hospital or my doctor or whatever. So what we're seeing is this happening in chemicals, it's happening in life science, in health, in the industry. And this is what I think will give this whole topic a big boost, is if all these industries start setting up their data spaces and they interlink them as well, then it gets really, really interesting. And that's why I'm so convinced of this topic. As with all trends, it won't happen in the next 1 or 2 years. It's not like the big rocket science that will change the world, but it will come slowly and steadily and it will change quite a lot, also in terms of AI. So the European Union right now is looking into how to create competitive AI. They will set up a funded project or subsidized project for this as well. And the idea is, in compliance with the European philosophy around data protection, is to say, okay, let's use these data spaces, the sovereign data of everyone, to train AI models, get competitive AI, but not steal the data from anyone for this, but use like the sovereign connected companies with their data to do this. And all these steps will lead to quite a massive development in this area, in my opinion. Yeah.
And are there any final words that you would leave our manufacturing audience with, who are interested in this and maybe on the verge of taking this step?
Yeah, I think the biggest message I have is talk. So what we see in Germany is that a lot of companies are coming together right now in this Factory X project where we are in. There are 47 industrial companies from Germany that are competitors in real life, but they come together to solve this infrastructure issue they're having right now. And I think that's what I would like to put out is that we need to understand that if we work in these kind of ecosystems, we have some kind of competition, right? So there are competitors working with me, and that's okay if we're creating infrastructure together that we can use individually afterwards. So this is not a lone wolf thing. This is teamwork, and it's a complex topic. There are a lot of experts. There are a lot of people who are new to this, and the most important thing is to network, get into touch with people who work with this, and first of all, get an idea what can this bring to my business.
Yeah, dialogue is always very important. So that's great advice. Well, thank you, Johannes, for joining us today. You've shared a lot of great insights about data spaces and digital twins and where the industry is heading. It's been very informative for us and for our audience. We appreciate you taking the time. And if listeners want to learn more about Arvato Systems, where should they go for more information?
We have a website, arvato-systems.com, and if you put in /industry/industrial-mid-caps, you will directly land into the manufacturing offering. But arvato-systems.com is the place to go if you want to find out more about what we're doing.
Great. Thank you. And to keep up with the latest manufacturing trends and hear more podcasts, subscribe to our podcast feed, and of course, visit us at advancedmanufacturing.org. Thank you for tuning in.